So in this video, we're going to focus on solving quadratic equations by using the ABC strategy, and we're specifically going to focus on factoring trinomials, which means items that contain 3 terms. And we're going to focus on trinomials that have an a value that is equal to 1. So we're going to focus specifically in this video on how we can factor trinomials using what's called the ABC strategy. So a trinomial is a 3-term polynomial, and in this case we're focusing on 3-term quadratics, and we can tell that it's a quadratic equation because of this squared being the highest power of x that we can see. So from here, if we're going to factor a trinomial, we need to know what a, b, and c represent. Well, a represents the coefficient of x squared, so it's always attached to your x squared. If you write your polynomial in descending order with the highest power first and the lowest power last, a will be your first coefficient or your leading coefficient. B is going to be your coefficient of just the x term, so no x squared, and c is going to be your constant. So after you write your quadratic and set it equal to 0, you're then going to identify a, b, and c, and we'll be using those values to help us factor a trinomial. So let's jump in and do our first example together. So the ABC strategy, remember, is used for trinomials that have a, b, and c values. And if you remember from Algebra 1, the ABC strategy is used to essentially undo the distributive property. So what we start off doing here, and if you need little steps written out, I'll try to write those out for you. Step 1 is to find a, b, and c. So we're going to find a is equal to 1, b is equal to 4, and c is equal to a negative 21. So that's our first step, find a, b, and c. Then, step 2, we would find a times c, which in this case is a negative 21, and our b value, which is equal to 4. And essentially what we need is we need two numbers that multiply to negative 21 and add to 4. So this is where you need to think through those factors of 21 and figure out which two numbers multiply to become negative 21 but add to become 4. And if you think through these, what you should come up with is 7 and negative 3. 7 and negative 3 multiply to be a negative 21, and they add to be 4. So now what we're going to do is we're going to take this original trinomial here, and we're going to rewrite this middle term of 4 as 7x plus negative 3x. So our third step here, if you are a steps person, our third step here is to rewrite this as 1x squared. Then we're going to use the 7 and the negative 3 to rewrite that 4x. So we have plus 7x minus 3x minus 21 is equal to 0. So then from here, we use factoring by grouping in step 4. So we pair these up, and we're going to factor out the greatest common factor, and our goal is to get those parenthesis parts to match. So here, if we factor out just a 1x, because it's 1 and 7, the greatest common factor is 1, and they each contain an x. So this becomes 1x on the outside, then 1 divided by 1 is 1, x squared over x leaves us with 1x. 7 divided by 1 is 7, and the x's cancel out. So then from here, when we factor out of negative 3x and negative 21, our goal is to get it to match this parenthesis piece. Well, in order to make that negative 3x become a 1x, we need to factor out a negative 3 here. So if we factor out a negative 3 divided by negative 3 is 1, and there's still an x. Negative 21 divided by negative 3 is 7. So notice as we use factoring by grouping that we have some matching parenthesis parts. Now what we can do here is we can say because 1x and negative 3 are both being multiplied by the same parenthesis part, we can actually group these together out in front and say we have 1x minus 3 times 1x plus 7 is equal to 0. So we're able to factor that trinomial by grouping together the two items that are both being multiplied by x plus 7. Now, we're not actually done here, but I'm going to take a pause for a second because I want to point something out to you. So, what's very, very special when A equals 1? And this trick only applies when A is equal to 1. If A is not equal to 1, we're going to have to show more work. But if A is equal to 1, there's actually a shortcut that would allow us to skip these two in-between steps here. If you look carefully, here in our parentheses we have 1x minus 3 and 1x plus 7. Well, if you look carefully, the values that we came up with up here in step 2 are the values that are inside of our parentheses here. We have 1x minus 3 and 1x plus 7. So if your A value is equal to 1, what you can do is you can actually skip ahead here and say, well, because A is equal to 1, and we have a positive 7 and negative 3, you can write x minus 3 times x plus 7 is equal to 0. So that's okay, as long as A is equal to 1. And then from here, we can use our zero product property. I notice I have something times something is equal to 0, so factoring helps us to use the zero product property. So I have x minus 3 equals 0, or x plus 7 is equal to 0. If we solve those two little mini equations, we end up with x is equal to 3, or x is equal to negative 7. So let's use that new shortcut that we learned when A is negative 1 to solve these two equations below. Now remember, this shortcut only works when your A value is equal to negative 1. So let's start off here and identify our A, B, and C values. So we see A is equal to 1, B is equal to negative 6, and C is equal to negative 40. Well, if I multiply A times C, I end up with negative 40. And I add to B, which is negative 6. So I'm looking for two numbers that multiply to negative 40 and add to negative 6. And if I think through the factors of negative 40, I think about 5 and 8, and I think about 4 and 10, and I think about 2 and 20, what I realize is that the two numbers that multiply to be negative 40 and add to negative 6 are negative 10 and a positive 4. Now, because my A value is 1 here, I can use my shortcut for factoring trinomials and change this into x minus 10 times x plus 4 is equal to 0. Remember, this strategy or this shortcut only works when A is equal to 1. So now we're going to solve this equation by using the zero product property because I have something times something equals 0. So I can set x minus 10 equal to 0 as well as x plus 4 equal to 0. Add 10 to both sides here, subtract 4 from both sides here. And as I do that, I see that I have x is equal to a positive 10 or a negative 4. So then from here I move on to example 2. Again, I start by identifying A, B, and C. So I have A is equal to 1, B is equal to negative 14, and C is equal to 48. Then from here, I need to multiply A times C. So I get 48. Add to B, which is negative 14. So I need two numbers that multiply to be 48, but add to be negative 14. So if I walk through the factors of 48, I think about 1 and 48, 2 and 24, 3 and 16, 4 and 12, 6 and 8. And what I realize is that negative 6 and negative 8, when multiplied, give me a positive 48, but add to be negative 14. So now I can use my shortcut because A is equal to 1. So I can say x minus 6 times x minus 8 is equal to 0. I have two items being multiplied that equal 0, which is the zero product property. So x minus 6 is equal to 0. X minus 8 is equal to 0. Solve those two. And we find x is equal to 6 or x is equal to 8.